All right, so the first question here, Jackson, would you read it, please?
A rare and delicate plant with only...
No, JT. He was the one talking.
A rare
And delicate?
decalate plant will only produce flowers from 10% of the seeds planted. To see if it is worth planting 5 seeds to see any flowers, the situation is going to be simulated. Which of these options is the best simulation for the others? Explain why it is not a good simulation.
Okay, so if they don't work, you need to explain why it's not. We even underlined it that. Right? If it's not, explain why. So to give full credit, of course, we needed to do that. So question A. Any issues with A? Looks like it's got the 10% down. Or do you want to leave that as a possibility until we go through the rest? Leave it? Okay. B, rolling a number cube 5 times. Each time a 6 appears, it represents a plant producing flowers. So how often does a 6 appear? 1 out of 6. Does that match 10%? So this one is out because the probability is not 10%. So that one's out. C, have a computer produce a 5 out of 0 through 9. So how often does a 5 appear out of 0 through 9?
It's 5 random digits.
5 random digits. Sorry, if a 9 appears. How often does a 9 appear out of 0 through 9? Well, 0 through 9, is that 9 numbers or is that 10 numbers? That is 10 numbers. So often does a 9 going to appear? 1 out of 10, which is 10%, and they did it 300 times. So right now that looks like a good possibility. How about D? Creating a spinner with 10 equal parts. One of them says flowers. You're spinning it. Is that 10%? All right, so we have 3 that work. Which one do you think is going to be the best? Jada. Why?
Because it's a computer and it's faster.
Faster?
It'll get you more.
And you're also doing it 300 times. A lot of trials. Okay, so then why would we eliminate A? Yeah, you're waiting 6 months. Too long. The 10% was right, but I don't want to wait 6 months. How about D? What makes D not as good as C? What's that?
It's only 30 times.
Yeah, you're doing 30 times, which is a lot less than 300 times. Remember, we've always answered, to be more accurate, we do more trials. Plus the computer doing it, it's going to be super quick. Us making the spinners and spinning them are going to take a while. Question 2. What is the area of the middle rectangle? Just the rectangle. 120. 12 times 10. How about the triangle? Yeah, 5 times 12 divided by 2 is 30. So they're each 30. So what's 120 and 30 and 30? 180 times the height. How tall is this thing? 2. 180 times 2. Label. Feet cubed. It is volume. All right, question number 3. 8% of students have asthma. They want to know the probability that in a team of 4, at least one of them has asthma. To simulate this, they put 25 slips of paper in a bag. 2 say asthma. Next, they take 4 papers out and record it. They do it 15 times. Jada says you can improve the accuracy by doing 100 slips of paper and marking 8 of them. Jada,
I agree with Alina
why?
because 30 trials is more than
More trials will produce a better simulation, better experiment. I actually 100% agree with that. Okay, for Jada's, you're not exactly improving how many times you did it. You're just adding more slips of paper. You're still doing it the same amount of time. Another way to represent 8%, other than slips of paper. Trey,
I said make a spinner.
I'm gonna put and what's your spinner gonna look like?
I put 25. Wait. No, I did it wrong.
How many did you have say asthma then?
2.
Yeah, that would be fine. I thought you were gonna say you had 100 spots on it, and 8 of them said asthma. 2 out of 25 would work.
Thinking of that.
Okay. Easy one maybe be 1 through 100. Computer can generate, or your calculator can generate a random number, and you could say 1 through 8 is asthma, and that means 9 through 100 would be no asthma. Trey said a spinner. He said 2 out of 25 would say asthma, which is 8% still. As long as it's 8%, it'll work. 4, matching. Cruz. A goes to 1. I agree with that. Matthew.
F goes to 4.
F goes to 4. Somebody other than Cruz and Matthew. JT.
The second one goes to 6.
Second one goes to 6. You're just distributing the negative sign, remember there. Got 3 left. Somebody that hasn't answered one. JT, you already did one. Right? Carson.
Not really sure about this, but I did. C goes to 3.
I do not have that one.
D goes to 3.
What's that?
D goes to 3.
D goes to 3. Lauren, do you have your hand up?
Yeah. 2 goes to 3.
I have E going to 2. C going to 5. And again, what you were doing there is looking at the x's. So for this one, for instance, that'd be 10x. Looking at the y's, that would be minus 10y, which is what this would be if you distributed 10x minus 10y. Okay, you had to watch the negative signs there, though, to be accurate.